If randomized controlled trials are the kings of research in terms of internal validity, then prospective cohort studies are surely the queens. Take, for example, the famous prospective cohort study conducted by Richard Dahl and Bradford Hill, where they followed thousands of doctors, both smokers and non-smokers, over many years to compare death rates. This was back when doctors were puffing away like it was a punchline in a tobacco ad. This classic study became a cornerstone of the Surgeon General's 1964 report, which concluded that smoking causes lung cancer. So, how do we rank the quality of the evidence generated from prospective cohort studies compared to other comparative studies? It's high quality. On the ladder of hierarchy based on internal validity, randomized controlled trials are high up in the sky, while prospective cohort studies are right there, next in line. Below them, you'll find retrospective cohort studies and case control studies. All these 4 study types are analytical or comparative studies, but they differ in internal validity. If truth was a warrior, think of internal validity as the shield that blocks out threats such as bias and chance. The bigger and stronger this shield, the less likely our findings would be spurious. Every single phenomenon we observe in the world around us can only be explained by one of 3 things: truth, chance, or bias. The goal of research is to find and report the whole truth, but to do this, we must first get rid of the influence of chance and bias. Otherwise, what we might end up with is the whole truth, which is truth with many holes in it. Randomized trials offer the best protection against threats to internal validity because they are experiments, while all the others are observational studies. What's the key difference? Well, if our study is comparing 2 groups, say A and B, it all boils down to who gets to decide which study participant goes into Group A or Group B. In the entire universe, only 3 agents are responsible for making this assignment: nature, nurture, or the investigator. Nature represents our genes. Nurture represents our environment, which encompasses everything from what we eat to where we live. The investigator is the researcher. When the assignment of people into groups occurs naturally, or we self-select based on our lifestyle choices, we call this an observational study. However, when the investigator makes the assignments, we call it an experiment. The reason why randomized trials are the top dogs in internal validity is because the investigator randomly assigns participants into groups by throwing a dice, ensuring that those groups are nearly identical, except for the different interventions they receive in their respective groups. In fancy epidemiology lingo, we call this exchangeability. So, if we removed experiments from the picture, what makes prospective cohort studies so special compared to the other observational studies? Don't they all carry the same baggage in terms of biases and limitations? Well, not necessarily. In the kids' storybook called Animal Farm, the pigs famously declared, "All animals are equal, but some animals are more equal than others." The same goes for observational studies. Prospective cohort studies are in their own VIP section, thanks to the keyword prospective. What does that mean exactly? It is important we know the difference between prospective cohort, retrospective cohort, and case control studies because many researchers get them mixed up. To explain their differences, we'll use a fun analogy involving a chef we hired to teach us baking. Imagine 3 scenarios that represent our 3 study types. In each case, the chef shows up in the morning, gathers the ingredients, and whips up a delicious cake. Here, the ingredients are the exposure, and the baked cake is the outcome. In all 3 studies, the exposure happens before the outcome. Pretty obvious, right? After all, you can't bake a cake without the ingredients. The real difference is when we, the investigators, come into the picture. In a prospective cohort study, you're there from the very beginning, watching the chef gather ingredients and tools. You see everything, the mixing, the baking, and everything in between. Your notes are spot on because you witnessed it all. This corresponds to a prospective cohort study, where researchers follow participants from start to finish, capturing all outcomes as they occur. For a retrospective cohort study, imagine you weren't there when the chef started, but you had a video recording of the entire process. You can rewind and watch the chef from start to finish. This is like a retrospective cohort study, where the investigator starts after everything has already happened and the outcomes are known. Just like the video lets you relive the cooking adventure, existing records such as hospital notes or other official records help researchers piece together a timeline of exposures leading to outcomes. It's like time travel where we can go back in time virtually and follow the participants from start to end using the pieces of evidence they left behind. Now, in a case control study, you arrive after the meal is cooked, and oops, there's no video. The only way to figure out what went into the cake is for you to play detective and reverse engineer the cake by breaking it into crumbs and carefully inspecting. Likewise, with a case control study, researchers start with the outcomes and work backward to identify the exposures. Now that we clearly understand the differences among these study types, let's address the main focus of this video, which is sample size calculation for cohort studies. To do this, let's hop over to the Chisquares platform. The statistical principles for sample size determination are similar for both prospective and retrospective cohort studies, so we'll tackle them together. For this example, we will assume our cohort study seeks to examine the relationship between smoking status and incidence of severe gum disease. Once we've logged into the platform, we head over to the sample size page and choose our study type as comparative study with 2 arms. This is because a cohort study has 2 groups, the exposed and the non-exposed groups. We'll choose percentage as outcome. Next, we have to enter the prevalence or incidence of the outcome among the non-exposed group. In other words, what percentage of non-smokers do we expect to have severe gum disease? Let's assume this as 8% based on our literature review. Then, we specify the smallest difference in severe gum disease we want to detect between smokers and non-smokers, using a prevalence ratio of 1.5. This means we're looking for a situation where smokers are 50% more likely to develop severe gum disease compared to non-smokers. We set a 95% confidence level and choose a two-tailed test because we don't want to assume the direction of the relationship between smoking and severe gum disease. Next, we provide a power of 90%. A higher power means we need a larger sample size, which in turn ensures we don't run into the problem of false negative results, also referred to as a type 2 statistical error. Since we want about the same number of people in both exposure groups, we enter 1 for the ratio of exposed to non-exposed. Next, we have to provide the anticipated response rate. Now, this is where we need to think carefully about the difference between prospective and retrospective cohort studies as far as sample size calculation is concerned. In a prospective cohort study, we expect some drop-off because, well, life happens. People might stop participating in our study because they moved, can no longer be reached for one reason or another, or even died. So, we need to account for possible attrition. Let's go ahead and put an estimated response rate of about 60%. We may have to offer incentives to participants to achieve this level of participation. Note that if this were a retrospective cohort study in which we were merely abstracting existing data without any contact with participants, we would simply assume a 100% response rate. And just like that, we've racked up our sample size calculation. The app tells us we need a total of 3,942 participants for our prospective cohort study, half in the exposed group, which is the smokers, and the other half in the non-exposed group, which is the non-smokers. You can even click on Show Reference to grab the formula and citations for your work. Congratulations! You can now calculate sample sizes for cohort studies using the Chisquares platform.